Well, the project for this week is I'm going to fit a winch to this winch down here to my 2018 Isuzu DMAX. The DMAX that I have had a factory alloy bull bar, which I don't want to get rid of, mainly because I don't want to pay for a new bull bar. And you can't mount winches to your alloy bull bars, or at least not this one. I could buy a winch caddy that'll apparently fit this bull bar, but they're around $700, and I've got everything I need to make one, so I've not done something like this before for a four-wheel drive, so I thought I'd give it a go. I've gone ahead and just removed the bull bar, made sure that the winch is going to fit, which I thought was pretty important, and then I've gone ahead and cut the hole that you can see down there for this faceplate that the rope of the winch comes through. So that fits in there like that, all nice. And I believe that that's about all I've done. So the next step will be to model up the winch caddy, which will mount from this plate over to the same plate on the other side, and we'll have a flat section coming out that the winch will sit on. I want to model that up in Fusion 360 because I think it's just a good process to make sure I test the design to the capacity of the winch, which is, it's a 12,000 pound winch, so that's 6 ton thereabout. And so I want to simulate the design to make sure that it's strong enough and not going to fail if I go to use the winch. So this is the winch caddy designed in Fusion 360. You can see the main plate that goes between the two chassis rails of the DMAX. One chassis rail coming back up here, the other one up here. You can see the main plate that the winch is going to sit on, and then a good amount of bracing for structural support. I've also got a few extra shapes in here, these two plates at the back to simulate the front of the chassis, and this block that you can see acting as the winch. Those shapes are used for the simulation. Now, when I first simulated this, it wasn't strong enough. This plate was flexing. I didn't have this brace or these braces. I only had the 4 braces underneath. With that, it only had a factor of about 0.4 before distortion started to occur. The distortion was in this main rail. Now, I thought to add these braces right at the point where the chassis rail meets, and that's because this is going to be a shearing force across here, and shear strength of metal is really, really strong. And so adding those in and running the simulation, let me just flick to the simulation, you can see that we're at a factor of 1.007. It was higher than that before I added these cutouts. Those cutouts are for the motor and the planetary gearbox assembly of the winch. So they're necessary. Now, that's a static load analysis. I don't know if I should be doing a dynamic load. I'd love for anyone to comment if you've got an idea on what I should be doing there. And that's at the 12,000 pounds. So I'm hoping that that's good enough. I'll keep an eye on it, check it out, particularly at the points where it's yellow here, just to make sure everything's okay once it's built. But as it is, I'm happy with that. I'm going to move on to fabricating this thing. I'm going to plasma cut out the bits of plate steel, weld it together, squirt some paint on it, and then start assembly. So here's the winch caddy. This is the underside. So you can see these braces that we saw in the Fusion 360 design. I've gone ahead and added a few little tabs out the front to take the winch faceplate. Okay, so this is the top side. You can see the winch mounting holes in here. I've got another hole to let water drain out of it so it doesn't rust. And you can see these mounting plates are also braced. Well, I have the winch all mounted in now in the caddy, in the bull bar. Got the electric box down to the right hand side of the bull bar there under the indicator. I'm going to use the wireless control for that, so I don't need to get under, but even if I do need to use the wired controller, you can get your hand up in here and access the plug quite easily, so long as you're not in a ditch. Cables come through the hole that was already in the bull bar there, connect to the motor. I put it all together, I had to pull it apart because I didn't realize there's a terminal underneath for the earth, and so I've just got to wire up those together. I've drilled a hole through the bull bar into the winch caddy and fixed a high tensile bolt both sides, and so that holds the winch caddy to the bull bar. It's fixed as a unit. There's these hooks here, they're useful for getting it slung onto the vehicle before you start bolting it up. The alignment is all pretty good. I'm very, very happy. So it's just getting it up onto the vehicle now and then wiring up the positive and negative to the battery. So it's all done. I'm pretty happy with the end result. It was fairly easy to lift the bull bar onto the car. I just had to get my wife to help me get those hooks on the front plates of the chassis rails, and then I was able to bolt it all into position. The winch looks pretty good in there. You can't see it very much, which is what I love. It's nice and concealed. Once I get the number plate screwed on, you won't see any of this plate. You'll hardly know a winch was there. The clutch knob that is on top of the winch motor there, I can get to that by opening the bonnet and reaching my hand down behind the grille. I can reach to that so I can access it as it is, but if that gets frustrating, I could just cut a hole in this front grille. So that's all done. You can see the caddy that I made up in under there. I'm going to call that complete. So thanks for watching.